Hi everyone. Today we're going to learn about the transformation called a reflection. So remember, transformation means you're working on changing something, a shape, a point, whatever it may be. And a reflection is a transformation that, or I guess which flips, this is a really not precise word, but that's okay, it flips the figure over a line. Okay, and this line is called the line of reflection. Let's see what this looks like through some examples. Okay, so in this example, you have a triangle ABC, and it's being reflected over the x-axis. Okay, what we want to do is we want to draw and label the new image after it's been reflected. So if it's ABC, we'll call the new one A prime, B prime, C prime. Okay, so we're going from ABC to A prime, B prime, B prime, C prime. Keywords here is you're using a reflection, and you are reflecting over the x-axis. Now the x-axis is a horizontal axis, so you're reflecting over this line. So the blue line I've drawn here is what we call, from above, the line of reflection. I'm just going to abbreviate that. Okay, so what you do when you reflect something is you flip it over that line. And the key to it is the original point and the new point have to be the same distance away from the line. So for example, if I want to take C and reflect over the line, I'm going to flip it over that line. It's going to come over here. Okay, now C is 2 units away from this line, or our line of reflection. That means C prime also needs to be 2 units away. 1, 2. So C prime will be this point right here. Okay, and you'll kind of see why this makes sense when I finish. Now B is on the line, so it means B prime needs to be on the line. And you can't really flip this point because it's on the line. So B also happens to be B prime. Okay, A is right here. It's 1, 2, 3 units away from our line of reflection. So A prime needs to be flipped over and be the same distance away. 1, 2, 3. So this would be A prime. We're just going to erase those because it's too much. And if I connect the dots, you will have a triangle that looks like this. Okay, so as you can kind of see, it looks very similar to our original triangle, but it's been flipped upside down. If you are having a really hard time visualizing why this is a reflection, what I need you to do is pause and ask Miss Mancini or your teacher to come bring you some patty paper and show you why this makes sense. Okay, if you are having trouble visualizing, please raise your hand right now. Otherwise, we're going to write the coordinates of our original points and our reflected points. So original point A, we went 1 on the x and down 3 on the y. Okay, our original point B, let's see, was at 1, 2, 3 on the x, and you're moving up 0 or down 0. So 0 on the y. C was at 1, 2, 3, 4 for the x, and then it moved down 2. Okay, whereas A prime, and I should probably make sure I have my prime on the A there, A prime went to, let's see, 1 on the x, and we went up 1, 2, 3. Okay, B prime stayed the same. Should do it in the same color, right? Stayed the same. So it's 3, 0. Because you can't really flip it over the line because it's on the line. And C prime went to 1, 2, 3, 4 on the x, and up 1, 2 on the y. Okay, so these are original points, these are our reflected points. The question becomes, how does our original relate to our reflected one? What do you notice about these 2 points? Well, I noticed the x-coordinate stayed the same. Okay, the x-coordinate is 1 on both, but the y-coordinate almost looks the same, but what's different about the y-coordinate? This one's negative, this one's positive. Okay, now B stayed exactly the same because it didn't really have to flip because it was on the line. So how do we relate C and C? So our 4 is the same, this 2 is negative, and this 2 is positive. So what we're noticing here is that our y-coordinate changed while our x-coordinate stayed the same. Why does that make sense? Well, for C, I was below the y-axis, now I'm above the y-axis. So I was at positive 2 away from the line of reflection, or I was negative 2 away originally. I was down 2, now I'm up 2. But the x is going to stay the same because it's in a straight line with our original point. It just got reflected over the x-axis. So the general rule, if you're reflecting over the x-axis, Means your x-coordinate's going to stay exactly the same, but your y-coordinate is going to be the opposite sign. So it doesn't necessarily mean it's going to be negative. It means whatever it is, you're going to take the opposite sign. So if our original coordinate was -2, our new coordinate is going to be the opposite. Okay, it's going to be +2. If our original coordinate was -3, our y-coordinate is now going to be the opposite. It's going to be +3. And the reason that is because you're really reflecting vertically. So I'm really changing the vertical distance of my coordinate from positive to negative, okay, because I'm reflecting over the x-axis. I'm leaving this question for you to do on your own. I want you to tell me if the original image and the post image are congruent or similar or neither. I also want you to tell me what are the differences between the shapes. So how are they the same, the two triangles, and how are they different? That's for you to do on your own. Example 2 is very similar. You have ABC. This time, though, you're going to reflect it over the y-axis and draw the post image as A prime, B prime, C prime. Post image, post means after. Okay, and then find the coordinates. So I'm going to reflect over the y-axis. That means our line of reflection is this line here. So what we know is that when you reflect something, it's got to be the same distance away from the line of reflection. So for example, A is 1 unit away from the line of reflection. So we're going to go in the other way 1 unit to get A prime. This is A prime. So they're both 1 unit away from the line, but one goes to the left, one goes to the right. Okay, now we're going to do B is 1, 2, 3 units away from the line. So B prime will be 1, 2, 3 units away in the other direction. So this one goes right 3, this one goes left 3, and they'll be reflected. Now C prime is 1, 2, 3, 4 units away from the line. So now it's got to be 4 units going the other way. 1, 2, 3, 4 on the other side of the line. That's C prime. And if you've done your reflection correctly, it should look like a mirror image. So let's just connect those dots and make sure it looks like the same shape, but flipped over the line. Which I didn't draw a perfect triangle, but it does look the same. So original A was at 1, -3. Original B, oh wait, this is the same triangle, so it's going to have the same points, right? This is at 3, 0, and our C was at 4, -2. And now what are our A prime, B prime, C prime? So now our A is at -1, down 3. Our B, let's see, was it +3, 0? Now we move this way, so it's at -3, 0. Our C was at +4, -2. Now our x is -4, and we're still going down -2. So which coordinate changed in this case? Okay, let's compare. So we had 1, 3, -3, and we have -1, -3. So our y stayed the same, but our x's are different. So here I had 3, 0, now I have -3, 0, so that -3 has changed. Here I had 4, -2, now I have -4, -2. So this time, we're looking at our x-coordinates to change. Why are our x-coordinates going to change even though we're reflecting over the y-axis? Now, this is a very similar idea to what we talked about above. So if you're going over the y-axis, you're flipping over this line, you're really moving the triangle from left to right. Like we're going over here, that's moving horizontally. Even though it's over the y-axis, and you might think you want the y's to change, you're moving the shape horizontally, so it's going to change the x, because x is our horizontal axis. Okay, so the rule here is kind of the opposite of our rule over here. So our x is going to become the opposite sign, while our y's are exactly the same. So y is going to stay the same. So this is going to be the opposite of x. Not necessarily negative, the opposite. And this one's going to stay the same. That's our mathematical rule. Okay, so when I say opposite, I mean like if this is 1, it now becomes -1. If this is 3, it now becomes -3. If this were -3, it becomes +3. I take the opposite. Okay. Again, I want you to answer this on your own. I want you to tell me the similarities and differences of the shape. Okay, so that is what reflections are. It's a mirror image. It's flipped over the line. The key is that it has to be equidistant to the line of reflection like I have here. These are the mathematical rules that you need to be able to write, just like we did for translations. So just keep those in mind. But otherwise, that's all I have for you today. There's a problem for you to try on your own, and I left these problems to try on your own as well. If you have any questions, though, please, 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 if you're not comfortable with this, raise your hand and ask. Otherwise, have a good rest of your class period.